Hello and welcome to another Out of Spec Reviews video. In the last few videos, we've talked about driving and towing with the Silverado EV, but in this video, we're going to talk about charging it, specifically charging it off of GM's Hydrotec solution over here. This is an in-house developed, essentially hydrogen-powered DC fast charger. That's really fascinating to me because there's a lot of fleets, there's a lot of rural applications where getting high power out to the middle of nowhere is tough. You guys know we've been planning some crazy adventures on our side in electric vehicles, and we're looking for a towable charging solution, if you will. And we'll talk about the limitations of the system, the pros, the cons, and some of the engineering that went into the work here. So really fascinating stuff. So let's get into all things GM Hydrotec charger today. And I think you guys are going to love this one. We have one of the coolest engineers ever to explain all this to us. So let's nerd out about DC fast charging powered by hydrogen. So you join me over here with Mike Bearman, or is it Bearman?
It's Bearman.
Hey, Mike, how's it going, sir?
Nice to see you.
Nice to see you. Thanks for taking the time to show me around all of this stuff. We have a Silverado EV with a huge battery pack in it. You guys are always out testing and developing your vehicles on your own test loops. Are you using the Hydrotec charger to charge up your own stuff?
Yeah, absolutely. So we've had it at media events, we've had it at multiple vehicle launches, and then we use it for development and even manufacturing. So it's kind of been on all over the place with thousands of hours of operation.
Amazing. Cool to see and great to see it here charging up all the trucks. It's way cooler than other events that we go on. Sometimes they're powered by diesel chargers in the back. This is like next level. So I thought we had to make a video about the Hydrotec charger. I've been trying to make one for a long time. And what's been your role in this Hydrotec charger?
So I'm program manager of several of our government applications, and we developed this as part of a government project. It's very flexible. It can be used in the field to produce power, but it can also be used to DC fast charge vehicles like this.
Right.
So my role, I've been fielding it all over the country. We've been in probably around 10 states. It's been international, very capable system.
Oh, very cool. So you have a fleet of these dispensers then basically.
We do, yep.
That's so cool. Well, let's first talk about, I guess, hydrogen's application, because I certainly am not well versed in hydrogen. I understand DC charging and a lot of the stuff that happens after the hydrogen. Can you walk us through that as a fuel source? Because to me, it seems slightly inefficient than just plugging into the grid, but what's your take on that?
Yeah, I think this is all about getting energy where you need it. So a grid might not have the infrastructure to do what you want to do. I mean, you can look around here. We're very close to power lines, but those power lines, it would be very difficult to put a DC fast charger here in a short period of time. It'd be probably pretty expensive too.
Very, yes.
I've seen a lot of different solutions for DC fast charging, everything from like battery buckets to generators. And I think when you're looking at fuel cell, it's one of the only kind of mainstream technologies that's zero emission and actually produces energy.
Right. So let's talk about that zero emission for a second,
Sure.
Because there's a couple different ways to generate hydrogen. There's, what's kind of called clean hydrogen, which can be from an electrolyzer off of solar, for example, and then stored. And I definitely want to take a look at your storage solution here because this thing is badass. But then there's also natural gas produced hydrogen. How do you choose what hydrogen to use to power this?
Well, right now we're basically trying to get what we can get. We always try to move towards more green, and so there are kind of different layers to that. There's a color code on various fuel cell and hydrogen sources, but generally speaking, the closer that you can get from solar or wind, that's the greener it is, and then the closer you get to natural gas produced, that's probably the less green.
Right, sure, that makes a lot of sense. So obviously filling up hydrogen is an interesting situation. We were talking about that a little bit earlier. Just to fill up this trailer, for example, you had to have quite a distance to get it charged up, if you will, or filled up. What does that look like for this solution? If you're a contractor and you're bringing a few trucks out to the middle of Montana, obviously you would fill on the way. How would you get this filled up, basically?
Okay, a little bit of that is where we are now versus where we're going as a country. Right now, most of our hydrogen is produced through natural gas. And so if I were to be buying hydrogen, which I've purchased a lot of it, basically what we would do is go to a site as close to where we're at and see if we could procure hydrogen there. As initiatives like the Inflation Reduction Act or other U.S. initiatives are pushing towards green, there's going to be the availability of more green hydrogen products locally. So there was recently an announcement about a project with Nell producing green hydrogen in Michigan. There's also a lot of other projects that are coming online in the next few years, and our overall goal is to transition to those sources of hydrogen.
Makes a lot of sense. And before we get into the actual trailer with this on here, I just want to give a quick sneak preview as to what we're going to dive into in this video, which is sort of the operation of this right here. But this is fed from a hydrogen source. How would you even describe how this works? What's your elevator pitch for this solution?
Yeah, so we have a zero emission DC fast charger, and if I need 3,000 kilowatt hours of energy, I just call up a fuel company, they'll meet me here, and we'll be charging.
Wow, very cool. So basically it can charge at, you mentioned about 60 kilowatts continuous for this application, but of course can be sized in the future for whatever's needed.
Yeah, so GM strength is with vehicles, of course, and so a lot of the generator platform is very similar to like a fuel cell vehicle. It's got a lithium battery on board, which allows us to boost the power up to 100 kilowatts in this case.
Okay.
And then the fuel cell system on board, which GM's also a leader in, we're able to produce a steady state about 77 kilowatts. So some of that's used to keep the system running, and then basically everything else is used to charge a car.
That is super awesome, and we'll definitely be charging this truck in this video. Before we get to it, let's talk about this trailer. Now, this is totally sized for this event that you're doing, where you're launching Silverado EV work truck, and honestly, probably based off of the range in these things, probably oversized for what you're doing. But can we show what's in the back over here?
Absolutely, yeah.
What's the equivalent energy capacity in sort of megawatt hours that's in this trailer, if you get what I'm asking?
Yeah, so in this trailer, we've got about 3,500 kilowatt hours.
Okay, wow.
3.5 megawatt hours.
Yeah, so 3.5 megawatt hours just in this trailer.
Yes.
And you can tow it behind a typical dually pickup truck.
That's correct.
You could not do that with batteries.
Not with that much energy. I've seen similar solutions, and they might be, a similar size, but you'd see maybe less than a third of the energy storage. That's where really hydrogen's valuable when you look at it from a energy per unit weight perspective. It's very good.
Right.
There's some disadvantages per unit volume. So this is a big trailer, but it basically is just a bigger trailer. It might have the same mass, though. You size it appropriately.
Certainly. And so inside this trailer now, is this something that GM owns, or you're renting the trailer, or how does that work?
So this trailer we essentially own. It's from 1H2.
Okay.
There's a number of hydrogen companies that we've worked with for hydrogen. This is kind of a unique trailer. It stores hydrogen at very high pressure. Around 7,000 PSI.
Wow. Okay.
And a lot of the industry is anywhere from 6 to 5 to 4,000 PSI, but this being a higher pressure allows us to also use it to kind of fill vehicles.
Certainly.
So it's valuable from that perspective.
So you could fill a hydrogen car with this.
We could. Yes.
Nice. That's very cool. So that's sort of a one-stop trailer. If you're testing a hydrogen car or potentially working on one, you could in the future just pull that up, fuel it, or you could hook it up to the Hydrotec and charge your truck.
Yes.
Okay, so let's talk about what I think our audience will be mostly interested in, which is, once you get the hydrogen output, which is coming out of here, is my understanding, and then it's coming out of this line, I guess. How does that actually work?
Yeah, so this trailer stores at about 7,000 PSI. It goes into a cabinet here, which the pressure is dropped down to around a few hundred PSI, and then it goes into our system.
Okay, so this is basically a pressure derater. I don't know the correct
pressure
way.
Regulator.
Okay, pressure regulator. Very good. This is all different terminology than electric cars, typically. Okay, and so then you have your output and then a return. Is that why there's two lines?
Yeah, so whenever you make a connection on a fuel cell system, you're basically using a compressed line, and so there's a safety system where this essentially vents the line when you remove it. So I can remove it, it vents when I remove, I plug it in,
Wow,
There you
that's super simple. So let's say, you're someone who wants to buy your solution. You want to power your fleet for the, 2-month job that you have out in, again, the middle of Montana, as an example. You can roll one of these trailers, you hook up your cable, you do exactly what you just did there, and then you're done.
Pretty much. One of the things I try to do is work with hydrogen companies as local to the events that I go to. And one of the advantages of that is we get to test with different companies and see kind of compatibility with systems. I've never really had an issue with that, which I think is kind of a good, speaking point for the technology.
Yeah, totally. That's pretty amazing how compatible it is with a bunch of different hydrogen solutions there. So, okay, now we have a hydrogen power source for this. Where does that go internally? What's going on behind the metal here?
Yeah, so inside, GM has designed what we call a fuel cell Powercube. Basically, the hydrogen goes in there. Normally you talk about black boxes. This is a blue box where it converts hydrogen from this trailer and oxygen from the air into electrical energy.
And do you filter the ambient air that's going into it and pressurize it? Is that how that works?
The filtration is just through your standard air filter that you might see in any fuel cell vehicle. It is a carbon filter, so it does remove VOCs, things like that might harm the fuel cell membrane.
Okay.
But it's just an air filter.
No, very cool. And so this is your actual stack, your Powercube, if you will, right here. So it can go, again, 200 to 410 volts output and up to 270 amps. Is that correct?
Yes, this system the system that we're going to production with is an 800 volt platform system, and that's kind of to meet the bigger power, higher voltage demands that we're starting to see in the market.
Right. Obviously, your trucks are going to need 800 volts and other things, but technically, this isn't directly feeding the DC side, is it? Or how does it work in this particular one?
It's kind of in the same architecture. What we do to be super efficient is we essentially boost the voltage up, and we charge a car using the voltage of the fuel cell system.
So you're not converting to AC and then powering an AC to DC, rectifier back to then match the truck. You actually took a really integrated approach with less losses.
Yeah, it's almost like if you were to build a fuel cell vehicle, we just kind of pulled out part of the fuel cell vehicle and put it right here.
That is so neat. And so on the DC side, where is the actual, is that on the other side of the trailer? Is that how that works?
So fuel cell is DC in nature.
Yes.
So
sorry, I meant to say the charging side.
Yeah.
Okay,
I understand.
Okay.
Yeah. So on the other side, we have the DC fast charging cable. It's just your standard CCS1 cable.
Right. So you're using in this case, you could hook up any cable, but it's just a Phoenix Contact 200 amp version. Although it's got the big HPC connection, it is only rated for 200 amps.
That's correct. This was a really early model. We've been in continuous development with this system.
Yeah,
so it's actually held up for quite a bit of time.
Right, but always good to carry a spare, which I know you do.
Yeah.
Very cool. So is there anything we can see inside of this cabinet here?
It's actually kind of storage. So
nice.
The original design of the system was to be, aside a building as a generator. And
is this everywhere that this trailer's been? This is great. I love it. It's been to Mojave and a whole bunch of places.
There should be more stickers on there, but I'm been busy.
Sure. That's awesome.
But as you can see, there's a forklift and a skid mount, and around a few years ago, we've noticed that this needs to travel a lot. So what I did was I worked with Zerkia Trailer Company. We put it on a standard generator trailer, and we don't use this cabinet as much anymore.
Sure.
Originally, this was so you could package it and ship it anywhere, which we do. But the easiest way now is to just pull it around.
Very cool. So this cable is obviously feeding your DC to DC side of things, which is where you can match the voltage of the truck for charging, or the car, or whatever you're doing. But you mentioned earlier that you can charge at a peak of 100 kilowatts.
Yes.
And so you have a lithium battery pack in here using Ultium cells, if I'm correct.
This is an older battery platform, so it's not lithium in this system.
Okay, but it could be, or at least in the production ones to come. What are you planning on using?
We don't have any announcements at this time.
Okay.
But, this one is not Ultium.
Okay, makes sense. But you have a roughly 20 kilowatt hour battery pack.
Yes.
And so that battery pack will, of course, you can just run the system to charge the battery pack, I would imagine.
Yes.
So you can let it sit full. And then as soon as you plug in a vehicle, you'll get the battery pack plus the hydrogen system to give you 100 kilowatt output. Once you drain the battery pack, which on something like this is definitely going to happen within one charging session, then you're just derated on your DC charging. Is that correct?
That's correct. Yep.
And what is the derate output? You mentioned 70 something kilowatts earlier, but it's got to run some, extra to run the station.
Right now we have it set up. You're going to probably see around 50 kilowatts just based on current ratings and cals that we're running right now. But as you know, there's a lot of factors that can affect charge rate.
Of course.
The current on the cable, the temperature of the air, all kinds of things. Right now we'll see, again, probably 50 or 60. We've seen continuous up to 65 before.
Oh, very cool.
Conditions.
That's amazing. Good. Yeah, that's awesome. So what do you say we fire it up and plug in a truck?
Sounds great.
So what is that process to go through?
So I've left low voltage on. So there's a switch for low voltage.
And that's just a 12 volt system that's running off a typical car battery, I would imagine.
Yeah. And then I turn on the battery system. So I'm going to click that button, the light turns green, and now the battery system's on. We could be dispensing power right now.
Okay. And if I take a look, I'm noticing a few things on the system. So once the battery's on, it's instant. You can get power out of it. You don't have to wait for the hydrogen system to spin up. But when the hydrogen system does start, what does that process consist of?
So what we're going to do is we're going to start compressing air for the oxygen side of the membrane, and we're going to start injecting pure hydrogen on the hydrogen side of the membrane. It's a PEM fuel cell system.
Okay.
And so with that, what you'll do is I'll click the fuel cell mode right here.
There we go.
And the fuel cell system is starting up.
Oh, damn, you can hear it spin.
The turbine spin up.
So that's compressing the oxygen.
That's compressing the oxygen. Yep.
Wow, that is cool. It's fairly quiet compared to a diesel generator.
Yeah, and it won't get much louder than this. I think that's the other aspect that's really nice about these types of systems. You kind of got the best of almost all the worlds. You're zero emission. You can be battery only for 20 kilowatt hours.
Yeah, which is fine to run some tools or whatever you need.
Yeah, and if you need to be quiet, you can be super quiet. And then if you need to start creating energy and moving lots of energy at the touch of a button, you're doing that.
Very cool. So you have battery mode, fuel cell plus battery mode, and we can see we're operating at about 250 volts DC. Is this on the battery side or is this the fuel cell side?
Yep, so you can see battery, fuel cell, and then our DC-DC. So I can kind of monitor every aspect of the system in development. And, right now it says around 250 volts on the fuel cell side. Of course, fuel cell systems, as you start to load them, usually they'll droop.
Right.
So there's actually, a way that we can match bus architecture after that.
Oh, very cool. So you have a little buck situation that you can pull them up.
Yep.
And I'm noticing here your high voltage battery is at 22%. It was just at 20. So with nothing plugged into it, you're actually charging up your high voltage battery to create as much buffer as possible.
Yes. I was just charging before this, so it's a little bit drained.
Sure. But no, that's really cool to watch it happen in real time. So what's the process to actually plug in a vehicle? This one, just as an example, is at 60 or 70% state of charge, I think.
Yeah.
If we open up the door, let's take a look. Oh, it may not pop up.
I'll be able to see it on my screen.
Oh, okay. It'll communicate it over. Great. But I checked it somewhere around 70%, which the trucks can take 60 kilowatts around there.
Oh, yeah, for sure.
So, let's plug it in. Do you have to tell the unit that, hey, I'm about to dump a bunch of load on you, or?
No, the system is designed to be fast and kind of easy to use. So I plug it in. There's going to be two-way communication with the vehicle, and we're set up to just start sending power right away.
Wow. Okay. So we plugged in the truck. It's going to recognize things are going. It's got to go through its handshake process and all of that stuff.
So it's already started communicating. I can see that we're at 71% on the vehicle.
So you have your own DC fast charging menu here, which is super cool. So that's like what a charger display would show. So that one display is showing the charging session, and it just started charging there, I'm noticing. And it can also show a few other things as well as I get attacked by a bee. Okay, very, very cool. And there we go, 60 kilowatts output. Absolutely ripping. Makes very little noise. I could hear it spin up a little bit there. And that's really all you need.
That's all you need.
That's great. Great. Thank you so much for showing us this. This is such a great solution. So Mike, thanks for showing us everything on the Charger so far. There's a couple other things that I think we should show our viewers, which would be sort of the air management system of this, how you're cooling it, what's going on there, as well as, isn't there water that comes out of hydrogen situations?
Yeah, so our byproducts are really just water and electrical energy. The water is basically pure water. It's not really designed to be consumed, but it's pure. So you can kind of see it on the side here. The amount of water we make is directly proportional to the amount of energy we make, and you can kind of see the rate. At 60 kilowatts, we make about that much.
So that's 60 kilowatts worth of water byproduct, basically.
Yeah, per unit time.
Yeah, no, that's very cool. And, you know, we're hearing a lot of fan noise, and you were just explaining to me a lot of that actually isn't from the hydrogen process. It's from the thermal management of the system.
Yeah, as you can imagine, like a vehicle moving down the road, it has the benefit of that airflow across the radiator. Since we're not moving and we're making essentially as much power as a vehicle moving, we need to compensate for that. So that noise you hear, the reason we sound kind of like a air conditioner is because in some ways we are. We've got a bunch of radiators up top and they're drawing the air across.
Very, very cool. And that comes out straight out the roof there.
Yes.
That is super cool. Well, again, thank you for showing us this thing. Is there really any other things that you want our audience to understand about the application of the Hydrotec Charger, or what are your favorite things about it that we didn't touch on?
One of the things that I like about this is just being able to put a DC fast charger anywhere. A lot of times people are looking for the fastest charger on their app, but they kind of forget, the closest charger is, probably the faster charger. So it's been really a pleasure to work at events like this where I can put a charger right where we need it. And that saves hours of time just driving a charger.
Yeah, it seems almost next level to be able to, if you manage a fleet of vehicles, if you're an events company, if you're an automaker, doing testing or showcasing your vehicles, rather than having a fleet of drivers bring them and clog up the EA station down the street, which a lot of events they do, or bring in diesel generators, you literally brought a charger right to the event.
Yeah, no pressure on the local grid.
Yeah.
And, another aspect, people will kind of think, fuel cell's kind of far off. It's really not. We've had systems like this all over the country. I've been able to get hydrogen kind of everywhere I go.
Really? So that hasn't been a problem to get the hydrogen filled then?
Not for me, because I'm working really in a different network. Usually when you're trying to fill a car, you're looking for the car refueling, sites. And a lot of those, almost all of them are in California right now.
That's right.
I'm working with hydrogen suppliers that will bring me fuel wherever I go, and they will deliver fuel to me.
Wow, that is so neat. So almost easier to get this filled up than a hydrogen car then.
In a lot of ways, yeah. And I think the other thing that I like about it is, where maybe fuel cell vehicles haven't been adopted as quickly as, some have hoped. I think in this area, we've got a good mix of zero emission kind of products all in the same place. Instead of every vehicle being fuel cell, maybe some combination of fuel cell generators and electric vehicles is maybe a better mix right now. I
think totally agree. I mean, from my personal opinion, having battery electric for smaller passenger cars, light duty trucks makes a lot of sense to me. And in some cases, most, but having hydrogen to be able to do these things that, again, it's possible to do this with a battery pack and a trailer, but the costs go through the roof. The weight goes through the roof, and everything is just so much bigger and heavier.
And you'd have to hire someone to shuttle the battery pack back and forth, right? I had a company drop this trailer, and I moved this in at the beginning of the week. So, it's not that hard.
Yeah, that's pretty sweet. Well, again, can't thank you enough on the full tour. This is fascinating stuff. Perhaps we got to have you out for some of our EV testing days when we have like 20 cars we need to charge in the middle of nowhere. I'll call you up. Be like, you need a vacation to Colorado?
Sounds fun.
Yeah, well, thanks again, Mike. Really appreciate it. And there you go, the GM hydrogen. Well, this is really the storage. Here's where you have the conversion. And there it is, charging a Silverado EV. Thanks for watching another Out of Spec Reviews video. We'll see you on another one soon. Bye-bye.